is the first. Okay, so let's look at problem 12, which is 1/2 x 1 minus x squared to negative 1/2 times negative 2x and plus the square root of 1 minus x squared. I'm making sure that I copied it correctly. Yes. Good. The first thing I will attempt anyway is to simplify it as much as I can. And I will definitely multiply this by this and also by 1/2. So this will be negative 2x squared divided by 2 will be negative x squared. And this is 1 minus x squared to negative 1/2. And this is definitely 1 minus x squared to positive 1/2. Is this okay so far? Agreed? Then I realized that these two terms have a common factor. And the common factor is 1 minus x squared to negative 1/2. I have to choose 1 minus x squared to negative 1/2. I have to choose the smallest exponent. So from the first term, this entire quantity is out. So what is left is negative x squared plus. Now, from 1 minus x squared to 1/2, if I take out 1 minus x squared to negative 1/2, it means 1/2 minus negative 1/2, which is 1. So that's why I have this. I combine like terms. I bring the negative power to the denominator in the form of the square root of 1 minus x squared. And now the numerator is negative 2x squared plus 1. And I highly recommend factor out negative 1. 2x squared minus 1 over the square root of 1 minus x squared. And this is a simplified form of that expression. We can look and see what my colleagues came up with. I don't know where it is. Yeah, they did not factor out negative 1. I highly recommend it, though. For the next course, that is important. Okay. Next question. Question here. Anything? Remind me, last time did we look at the piecewise defined function? We did. Okay, good. On page 126, is there anything else from any supplement that you would like to work on? Okay. So on page 126, I like to look at some equations. I like to look at some inequalities. One inequality, one equation. And problem 132. So I'd like to look at 77. I would like to look at 80. 93. 91. Sorry for not writing them in ascending order. And 132. Do we need to go back to the circle? Or are we okay with the circle? Okay, perfect. So in 77, we have x divided by x minus 2. So this is 77. And then plus 1 over x plus 2. And that equals a divided by x squared minus 4. Now, if you remember, if you like the method I like to work with or use, you will use this, but you don't have to. Use any method you like. So I moved the fraction from the right to the left, and it changes its sign, of course. In front I have negative now, and I have to have 0 on the right hand side. I will state 2 restrictions to make sure that I don't forget, because I may not go back and check, but if I write the restrictions, I will most probably remember that 2 and negative 2 cannot be the solutions. And then I will find the least common denominator to be x plus 2, x minus 2. And writing this, and I'm going to erase it, don't write it. Writing this at the top will be a terrible mistake. This will be a terrible mistake. Is that clear why? Because that's not how we add fractions. So this needs an x plus 2, this needs an x minus 2, and this needs 1. So this will be a terrible mistake. So this is x squared plus 2x plus x minus 2 and minus 8. One more time. X distributed to x plus 2 is x squared plus 2x. 1 distributed to x minus 2 is simply x minus 2 and then minus 8. And now I combine like terms at the top. And I get x squared plus 3x and minus 10 to be 0. How come? A fraction can be 0 only when the top is 0. Or you cross multiply. So this happens to be x plus 5, x minus 2. And I get 2 solutions, negative 5 and 2. And I will say not so fast. But I remember I stated a restriction before I even started. Any questions on this so far? This is a rational equation, and it's a very important type of equation. Okay, 80. So let's take a look at 80. 80, can anyone tell us what type of equation is this? Of course, and there are 2 options if you remember. 2x minus 5 equals 9. And 2x minus 5 equals negative 9. And now these are linear equations. I add 5, and I divide by 2, and I get x equals 7. I add 5, I get negative 4, divided by 2, and I get negative 2. Okay, 93. What type of, and what is this? It's an absolute value inequality. How do I change it? I cannot do anything to it. I have to change it into something that it equals to so I can solve. Okay, here's how I think. I'm trying to find numbers whose distance from 0 is 3 or less. 3 units or less, which means that x minus 5 must be between negative 3 and 3. So I'm going to add 5 to all 3 sides, and I have 2 less than or equal to x less than or equal to 8. And that is the solution. X in the interval 2, 8. Now I'm going to change the problem because since you didn't remember this, I would like to also review this one. What does this mean? Right, to the left of negative 3 or to the right of 3. So it does not include what's in between. That is already taken. So x minus 5 to the right of 3 or x minus 5 to the left of negative 3. As you see, what is between negative 3 and 3 is already taken by something else. So then this one changes into greater than or equal to 8, and this one changes into less than or equal to 2. So now this will always have the union. Less than or equal to 2 is negative infinity to 2, and greater than or equal to 8 is 8 to infinity. So this is the solution for this with a reversed symbol. This was 93, 91. And I would like you to tell me what type of inequality is 91. And in 91, we have x minus 4 over x squared minus 4 less than or equal to 0. What type of inequality is this? Yes. So I will have to factor the denominator into x plus 2, x minus 2 less than or equal to 0. And then if you like, please use the chart I showed you. If you don't like it, you have other options. What numbers go in the chart in case you decide to use it? So negative infinity, negative 2, 2, and 4. Very good. So there is a 0 here, there is a 0 here, and there is a 0 here. So each and every linear function has a 0 somewhere. X plus 2 under negative 2, x minus 4 under 4, and x minus 2 under 2. Now what happens when x is 4 to this? When x is 4, this becomes
0.
Very good. And when x is negative 2 or 2, this becomes, thank you. It turns out that all these linear functions have a positive slope, so they have to look like this. They come from negative and go positive. So I don't have to think about any of that. Three negatives, two negatives, one negative, and no negatives. Now I look here. Which sign is less than or equal to 0? Negative. So I see negative here and here, which means here and here. So x in the interval negative infinity, negative 2. I cannot include negative 2 because the expression is undefined. And then union, I cannot include 2 because the expression is undefined, comma 4. And that's it. That was 91. 92. Any questions on 91? Okay, 92. 92, we have 5 over x to the 3rd minus x squared minus 4x plus 4 less than 0. Okay. How do I solve such an inequality? And no, you cannot say multiply both sides by this because that's not going to work. Like here, you could have not said multiply both sides by x squared minus 4. I'm not allowed to do that. Okay. So when is this quantity negative, knowing that the top is positive? So what really am I trying to solve? The numerator is positive. What should this quantity be for the ratio to be less than 0? Negative. So really what I'm solving for is x to the 3rd minus x squared minus 4x plus 4 less than 0. This is what I have to solve. This is the inequality that this inequality reduces to. Okay. I see 4 terms. Every time I see 4 terms, what comes to mind? Grouping, right? 4 terms, always grouping. Okay, so from the first 2, I will factor out x squared, and I get x minus 1. And from the other 2, I have to have an x minus 1. If I don't, something is possibly, it's not factorable, or I did not group correctly, who knows. So x minus 1 has to be there. Okay, let's check. Yes, it is, with negative 4 in front. So that's why I have x minus 1 and x squared minus 4. But now I have to factor x squared minus 4. So x minus 1, x plus 2, x minus 2 less than 0. Again, if you like this chart, please use it. If you just want to write a real line, I'm fine with that, whatever works for you. In the chart, I have to put -2, 1, and 2. A 0, a 0, and a 0, and the product is always 0 when any of the factors is 0. I don't have to worry about anything being undefined. All of them again have the same sign, so it's -0 and then positive, -0 and then positive, -0 and positive. Again, I count 3 negatives, I count 2 negatives, I count 1 negative, and again I'm asked to find less than 0. So x in the interval -∞, -2, union 1, comma 2. Of course, I cannot have 0 in the denominator. This was a denominator, so. And also the inequality is less, strictly less. Okay, this was 92. Yes, and now I would like to look at 132. And they say Margarita is hired by an accounting firm at a salary of $60,000 per year. Three years later, her annual salary was increased to $70,500. 3 years later. Okay. Assume that her salary increases linearly. Find an equation that relates her annual salary S and the number of years T that she has worked for the firm. What do I do? What am I given here? We are given 2 points. So she's just now hired. She hasn't completed her first year. So what will be the first ordered pair? And then 3, comma 70,500. Very good. What do I do with this? I have to find the slope. So 70,500 minus 60,000 divided by 3 minus 0. Okay, so I get 10,500. 10,500, right. Divided by 3, and that is 3,500. Without a measurement unit, this means nothing. What is the measurement unit? Say it again. That's it. That's the rate of change of her salary per year. She got an extra $3,500 each year. Perfect. Part B. Oh, I didn't finish. So we want to find now S of T. How do I write S of T then? Yes, very good. T plus 60,000. Is that okay? Right? So this is 0, comma numbers, which is the B, the y-intercept, and 3,500 T. Is that okay? Part B. So this is part A. Part B. What do the slope of an S-intercept of her salary equation represent? So the slope, we already talked about it. It's the increase per year. And the y-intercept, which is this, is her initial salary. Part C. What will her salary be after 12 years with the firm? What will her salary be after 12 years with the firm? S of 12. 3,500 times 12 plus 60,000. So if you want to calculate that for me, I'll put it in. I want to add part D here. 102,000. Very good. Okay. So my question is, when will her salary reach 200,000? Assuming that that's possible with this firm, and assuming that the relationship still between S and T is still valid. In 4 years. So what do I have to do? So replace S of t, 200,000 equals 3,500 t plus 60,000. Yes, I have to subtract 60,000, so this is 140,000, and divide by 3,500 to get the t. So how much is 1,400 divided by 35? How much? 40. Okay, very good. 40 years with the firm. Well, that is possible. We have people who are retiring next week after more than 50 years with the college. So 40 years is not that bad. Okay, that's pretty much chapter 1. Let's review chapter 2. And a major topic in chapter 2 is the difference quotient. And this is half of the next semester in calculus. So the difference quotient is the big deal here. Okay, at the review problems on page 209. I'm trying to find functions with the difference quotient, and if I don't see them, and unfortunately I don't, I will have to make them up. Okay, forget about the book. So here it is, f of x equals 2x minus 1 over x plus 2. We're asked to find the difference quotient, which is f of x plus h minus f of x divided by h. Another function will be a quadratic function like negative 3x squared plus 5x minus 7. And I have to find the difference quotient for that. Another very important function will be f of x equals the square root of 3x minus 5. And we have to find the difference quotient for that. All these are super important. I'm just very surprised when I look at the review in chapter 2, I can't find one. Not even one. Okay, doesn't matter. Good, so let's start with the first one. So the only thing that is not given in the difference quotient is this quantity. So every time I'm asked to find the difference quotient, I have to calculate f of x plus h first. So I can put it together. Then I will have this, I will have this, and I will have that. So for the first function, f of x plus h is twice x plus twice h minus 1 over x plus h plus 2. Are we comfortable with this? And before I forget, I took a picture of my schedule for next week. Our final exam is scheduled for Monday, a week from today, from 5 to 7. But if you say, we already talked about that, right? 6 to 8, that's fine. Now, is everyone okay with 6 to 8 next Monday? Yes? Okay, perfect. Just not, please don't forget, because I'll call you. Okay, so I have this piece now, so the difference quotient for this function would be 2x plus 2h minus 1 over x plus h plus 2 minus 2x minus 1 over x plus 2 divided by h. Knowing how this works, you have accomplished at least a month and a half from next semester. And I'm not kidding. Okay, so then, of course, I have to find the least common denominator and the numerator, which is? Very good. Excellent. This one needs what it does not have in the denominator, which is x plus 2. This one needs what it does not have in the denominator. And now carefully multiply, combine like terms, distribute, and so on and so forth. So let's do this slowly. So I have to distribute x to these three terms. So I will have 2x squared plus 2xh minus x, and then I will distribute 2 plus 4 plus 4h minus 2. So all I have accomplished so far is just multiply these two and put them in here. Now I have to be very careful because there is a minus in front of the fraction line, and I have to distribute 2x to these three terms, but actually negative 2x. So it's negative 2x squared, negative 2xh, and minus 4x. Now I have to distribute negative with negative 1. But since they're negative, negative, it's going to be 1. So I'm going to say plus. Of course, I ran out of room. So plus x plus h plus 2. Is this okay? Yes? I'm hoping now that a lot of terms go away. And some terms with h will stay. But this has to go away. This piece has to get simplified with something from the top. In all situations, in any difference quotient, this part has to go away. No matter which function you determine a difference quotient for, this piece, this little h in the denominator, must go away. Okay, not by erasing it though, but by factoring and simplifying with something at the top. Okay, so these two go away, these two go away, these two go away. I have a 4 that bothers me. Hold on one second. So 2x squared plus 2xh minus x. 2. I have an error here. So 2 times 2x is 4x. 2 times 2h is 4h. And negative 2. Okay. So negative 4x with positive 4x. And a positive 2 with a negative 2. And I look carefully now. This is left and this is left. So then the top is 5h over x plus 2 times x plus h plus 2 times, and I flip the denominator already, and now I see that this h goes away. So the simplified form is this. So this is the difference quotient for the rational function we picked. Now let's look at the difference quotient for the quadratic function that we picked. So I'm going to copy it here one more time. F of x equals negative 3x squared plus 5x minus 7. And I have to find f of x plus h. Negative 3, x plus h squared plus 5, x plus h, and minus 7. So negative 3, and when I square x plus h, what do I get? Plus 5x plus 5h minus 7. So this is negative 3x squared, negative 6xh, negative 3h squared plus 5x plus 5h minus 7. So now I have the piece that I did not have before. So now I can write the difference quotient for this function, which is negative 3x squared minus 6xh minus 3h squared plus 5x plus 5h minus 7 plus 3x squared minus 5x and plus 7 over h. Because of the negative in front, I had to distribute a negative sign, or negative 1, to all three terms from the function. All terms that do not have h must go away at the top. So that's how I knew that that 4 did not have a root place in there. So these two go away. These two go away. And these two go away. Now the remaining three terms, 1, 2, 3, have age, and I will have to pull it out before I simplify it. I'm not allowed to simplify in a sum or simplify terms. So then I have negative 6x, I have negative 3h, and then plus 5. Only now I can simplify and I write 1. And the answer is negative 6x minus 3h plus 5. And this is the difference quotient for the quadratic function that we just looked at. Isn't this an overkill? Well, it's not, because all these three are different. So let's look at this one now, the square root of 3x minus 5. Any questions on the difference quotient of the quadratic function? Okay, so the next function is f of x equals the square root of 3x minus 5. So the difference quotient, of course I have to find f of x plus h. But that's not difficult, because I replace x by x plus h and I distribute 3. 3x plus 3h minus 5. So now the difference quotient is f of x plus h, which is the square root of 3x plus 3h minus 5 minus the square root of 3x minus 5 divided by h. The question is, what do I do now? Any ideas? Because I cannot subtract radicals. Nope, because they're not the same. I cannot factor out because they're not the same. Exactly. Rationalize the numerator this time. That's all I can do. There is nothing else. So I'm going to multiply and divide by the conjugate of the numerator. So I'm going to say multiply and divide by the square root of 3x plus 3h minus 5, but plus the square root of 3x minus 5, and the same thing in the denominator. Very good. So now when I multiply the two denominators, I have no problem. H is in front, and I copy 3x plus 3h minus 5 with the square root plus this. Okay, now what? What do I do with the numerator? Well, I know a formula that will really help here. A minus b times a plus b. So what do I write? A minus b times a plus b is a squared minus b squared. So a squared is 3x plus 3h minus 5 minus, you can put in parentheses so you don't forget, minus b squared, because I have to distribute negative 1. Any questions on this step? Is this clear? So this is like a minus b, and this is like a plus b. So a minus b times a plus b is a squared minus b squared. A squared is this minus b squared is this. Is that better? Okay, so now I distribute 3x plus 3h minus 5 minus 3x plus 5 over h. I know all terms without h have to go away from the top, and I have to get rid of the h in the denominator. So 3x plus 3h minus 5 plus the square root of 3x minus 5. So these two go away, these two go away. There is a 3h left at the top. And the h1, h1. So 3 over the square root of 3x plus 3h minus 5 plus the square root of 3x minus 5. This is the difference quotient for this function. Let's square it. I want to find the domain of a function. Domain is always a big issue, the biggest, one of the biggest in graphing and functions and so on and so forth. So domain. I would like to look at problem 21 on page 209. We are given h of x, which is the square root of 4 minus x plus the square root of x squared minus 1. Here we also have to look at odd and even functions, average rate of change of a function, transformations, inverse functions. This is a long chapter, chapter 2. Okay, what do I have to write in order to find the domain for this function, which is basically a sum of two functions? So I'm looking for the common domain, actually, of these two. So what do I have to write? What do I have to write for the square root of 4 minus x? It can be 0. The square root of 0 is 0. It cannot be a negative number. So how do I write that? No, not the square root. Perfect. Now what about this one? Right, it's the same process, the same concept. Good. So I solved the first one first. So I have negative x greater than or equal to negative 4, but I have to multiply both sides by negative 1, and that will give us less than or equal to 4. So the domain of the first function is negative infinity to 4. Now the domain of the second function, x minus 1, x minus 2, greater than or equal to 0. Yes, you can use the chart or any other method you prefer, because it's anything beyond this is linear inequality. So x minus 1 and x minus 2. So 1 and 2, 1 and 2, negative, positive, 0 and 0, positive, negative, positive.
X minus 1, x plus 1.
So it would be, for greater than or equal to 0, it would be between negative infinity and 1.
No, the x squared minus 1.
Thank you. How did I get 2? Thank you very much. So the domain will be between negative infinity.
But then it's actually
Between negative infinity and negative 1, union 1 to infinity. So this is for the second function. But I'm not interested in the first, and I'm not interested in the second. I have to see where these two domains overlap. So here it is. 0, negative infinity, infinity. The first interval is between negative infinity and 4. I don't care for units. Don't bother with that. That's not important. And then between negative 1 and 1 to infinity. I have to choose the common territory. So what will be the domain of function h? The domain of the first function is this. The domain of the second function is this. And now I'm interested in the common domain. So the common domain will be
negative
to negative 1. Yes,
and then union 1 to 4.
that's it. Very good. Good, so that was the concept of domain and common domain. Let's look at the average rate of change of the function between the given points. So let's say we have 58 on page 209. And we are given f of x equals x plus 1 squared. And we are given x equals a and x equals a plus h. Find the average rate of change of the function between the given points. I don't see the points. I see two x values, but I don't see the points. How do I determine the points? So I have a point with x, with x being a, but I don't see the y value. And I have a point with with the x coordinate being a plus h, but I don't see the y value. How do I determine the y value when x is a for this particular function? Plug it in, right? So this is a plus 1 squared. And now what is the y coordinate for b? So it's a plus h plus 1 squared. Because now we want to find the average rate of change between a and b. So what is the formula for the average rate of change of a function between 2 points? Anyone remembers the formula for the average rate of change?
Change in y divided by change in x.
Exactly. It's the slope of the line passing through those 2 points. Exactly. Does anyone know what happened to Daniel? Okay, so y2 minus y1 over x2 minus x1. So a plus h plus 1 squared minus a plus 1 squared over a plus h minus a. These two go away, so the denominator is only h. Okay. You can square a trinomial, but it will take a while. Or we can use the formula that will factor. This will be like a squared minus b squared. So that will be a plus in the middle and a minus in the middle. I recommend this because it's easier to simplify than raise a trinomial to the second power. But the question is, what do I have here and here, and what do I have here and here? So how do I simplify that? Very good. A plus h plus 1 plus a plus 1 and a plus h plus 1. But now I have to be very careful because I have to distribute this to a plus 1. So minus a minus 1. This is the easiest thing to do. And now let's see what happens. This negative a with this positive a, this positive 1 with this negative 1, and all I have is h that will go away with h, but I have to write it one more time. So I have h in front. From here there is only h left. So in parentheses 2a plus h plus 2 divided by h. Simplify h, please write 1, and then 2a plus h plus 2 is the final simplified form. And that will be the average rate of change. And actually is the difference quotient. Okay. Determine whether f is even, odd, or none of the above. So important type of problem. So let's say part C on page 210, and the problem is 65. And we have f of x equals 1 minus x squared over 1 plus x squared. So in any event, what do I have to find? If it's odd or even or none of the above, I don't know. We'll see in a moment. But what do I have to find? Very good. F of negative x, 1 minus negative x squared over 1 plus negative x squared. But negative x squared is x squared. So this is 1 minus x squared divided by 1 plus x squared. It turns out that is the original function. And this is typical for what type of function? When f of negative x equals the original function, the function is even, which means if you were to graph it, which you will do more, we will review even now because we have chapter 3, you will graph it symmetric with respect to, remember, negative x and x, they don't make any difference. So it must be symmetric with respect to the y-axis. So if it's f of negative x is the negative f of x, has to do this. But if f of negative x and f of x are the same, there must be this. Okay. Good. Let's look at a function composition and then finding the inverse of a function. Yes, I want you to decompose a function. And problem 80. We're given a function uppercase T of h, which is 1 over the square root of 1 plus the square root of x. I would like you to find 3 functions, f, g, and h, such that t equals f, g, h. If this is given to us in that form, well, obviously, which one is the innermost function? If we talk about f, g, h, which one is the innermost function? The first one to be applied to x. Of course. This is the second one to be applied to h of x. And this is this third one to be applied to g of x, or g of h of x. Perfect. So then I have to start from the inner with h of x, and then next one in line, and then the outer. Innermost is h, inner function is g, and the outer is f. There is more than one correct answer here. So what will be the first step? So h of x is? 1 is a function. You could use 1, but I recommend 1 plus the square root of x. So now I get this number. I have one number here. Which function I apply next to this number? That's it. And now I have a number here. Which function I apply to this number? 1 over x. Very good. Allow me to stop my